Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 7 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a simple statement here. The value of y is directly proportional to the value of x. So that's going to give us our clue that we're dealing with direct variation. Sometimes you'll see directly proportional. Sometimes you might see this phrase varies directly. Either one means the same thing, that you have a directly proportional relationship. So we're dealing with y equals kx. So this is our direct variation. Now, you might be thinking that looks an awful lot like slope-intercept form. And if you do think that this looks like slope-intercept form, you are correct. So let's write slope-intercept. We'll compare the two real quick, and then we'll solve the problem. So slope-intercept form, y equals mx plus b. Obviously, the difference right there is that plus b. So both of these have a y, which is your dependent variable. Both of them have that x right there, which is your independent. So we're starting with the x, multiplying it by something. We're getting our y, right? There's our independent variable. So in the direct variation, the k actually has its own unique name. It's called the constant of proportionality. Kind of a long name. But it also serves the same purpose as this m, which we typically call the slope. So the k and the m are actually both the same thing. You can call them the slope, you can call them the rate of change, or even the constant rate of change. But they both serve the same purpose. So they're very similar. Obviously the difference here is this plus b. So that's the y-intercept. And we don't really have a y-intercept other than 0 for our direct variation. So if you were to graph direct variation, right, so let me show you a little sample graph up here. If that's our xy coordinate, it's always going to go right through the origin. Whereas if you graph something that's slope-intercept form, it's going to be offset a little bit. It's going to be close, but not quite through the origin. So that's the difference between the slope-intercept form and the direct variation. So when we're looking at direct variation, we have an x and we have a y. So we've got two of the three. We just don't have the k. So how do you find k? Well, y equals kx. Just divide both sides by x and you've isolated the k, right? So my x is 512. My y is 128. Okay, so that is going to be less than 1. And you know what? I have a sneaking suspicion 128 goes into, that's going to be 256. And that's going to be 3. That's going to be 4. 384, and add another 128. Yep, 512. Okay, so I was just adding 128 there. And so that's just a really fancy way of saying 1/4. So that's our k. We can either keep it at 1/4 or 0.25. So what is the value of y when x is 64? Okay, so y equals kx. We're still looking for a y, but I know my k, I'm going to keep it as a fraction. And when my x is 64. So all of this is just 64 divided by 4, which, yeah, a lot of work. But 64 is divided by 4 16 times. So my answer here is going to be C, 16